Hey everyone, it's Mr. Ray here. This is our last lesson in grade 10 applied math. Uh, Obviously we've had to cut some lessons out, so what I'm going to do this lesson is basically a lesson called common factoring. I'll explain what that means in a minute, but normally I would teach you like 3 different methods of factoring at this point in the course. I'm just going to stick with the most basic type of factoring, and hopefully, this is something you could learn and remember for grade 11. Uh, you're going to actually need to know more than this for grade 11, but the teachers, I'm sure, will be very accommodating based on these strange situation and circumstances we're going through. Um, but I want to give you something you could take away from factoring, at least. Okay. Um, so the first thing is, well, what is factoring? Um, so the official definition is the inverse function of expanding, and that sounds very mathematical. It's basically the opposite of expanding. Okay, so here's a good example. So let me start off with let me write it up here from scratch. Okay, so we've got this would be something that we would have known coming in to this unit. This is if you multiplied x with x plus 3. Okay, so what that means is the x is multiplying with the both of these things inside here. So the x is multiplying with the x is multiplying with the plus 3. X times x is equal to x squared. Okay, and x times positive 3 is positive 3x. Okay, so this direction is called expanding. We basically, expanding means get rid of the brackets and simplify. So what we did with lesson 1 when we multiplied 2 binomials, we're not going to do the opposite of that. That would be another lesson. But if we actually expanded, if we multiplied 2 binomials, we would get 3 terms here. So expanding is getting rid of the brackets by actually multiplying through and simplifying, combining any like terms. Okay, now if you look down here, factoring, so what we just did above, x times x plus 3, when we expanded, when we went this way, we got x squared plus 3x. Okay, so what factoring does, I basically give you the answer to this question and ask you to come up with the factors. What things did we multiply together to get this thing, to get this original question? Okay, so x, if we factored x squared plus 3x, you can see that that's actually exactly the same as x times x plus 3. So how do you do that? That's what this lesson is about. Okay, so what we have is something called the greatest common factor. Okay, so what the greatest, I didn't do a good job of explaining what that is. It's basically the biggest term that I could divide into all the terms in the original question. Okay, so the word common means I could do it to all the terms in the question, and factor is from factoring, and greatest is the largest. So the largest thing that's common to all 3 that I can basically divide each of the 3 terms by. Okay, so what we're going to do, we're going to do this step by step. So I mean, you can go back to this and read it, but it's probably not going to make a lot of sense at this moment. The first step of this is always first find the greatest common factor and then use it to common factor. Okay, so in this step here, we're not actually factoring, we're just finding the greatest common factor that we would use to then proceed and factor. Okay, so when I have something, I have these 2 terms, so the comma is just separating the 2 terms. So I have a 6x and a 24. What's the biggest common factor between these two terms? So, and that's the GCF. So the GCF equals. Now, I want you to break this apart into 2 steps. So the first step is just look at the number parts. So I have a 6 and a 24. What's the biggest number that I could divide evenly into both of those? Well, that would be a 6. Okay, so you might have to make sure that it's the greatest, because someone might say, oh, it's 2. Well, that is a common factor, but it's not the greatest common factor, okay? So you have to make sure that you've got the biggest possible number that goes into both, okay? So 3 would work, 2 would work, but they're not the greatest common factor. 6 is, okay? All right, so that's the first step. We just looked at the 6 and the 24, and then you look at the variable part. So you look at the number part first. This is the greatest common factor for the number part, and then we look at the variable. Now, we have an x in the first term, 6x, but we don't have one in the second. So that tells me that x is not common to both of them. So do I have a variable that's common to both? No, I don't. So do I put a variable here? No, because there's no variable common factor to both terms. So we're done. There's only a number greatest common factor. There's not a variable part. Okay, so let's go down here, try the next one. So this time we have 10x squared first term and 15x the second term. So again, first step, look at the number parts. We have a 10 and a 15. What's the biggest possible number that I could divide into 10 and 15? Well, this one should be easier probably. It should be a 5. Okay, so 5 goes into the 10, 5 goes into the 15. Nothing bigger goes into both. Okay, so we're done with the number part. Let's look at the variable part. So what do we have for variables? We have an x squared and an x. So the fact that we have an x in both tells us that for sure I can put an x here because there's an x common in both. Now the question becomes, how many x's could I put? Because here x squared means I'm multiplying by x twice. The single x here just means I'm multiplying by 1 x one time. So how many x's could I divide out of both of these? Well, only 1 because of that single x. Okay, this is really 15x to the 1, but we don't usually put the 1 as an exponent. Okay, now if you did, you could just compare and say, I need to take the lowest of the 2 exponents. Okay, so in this case I've got a 2 and a 1 for the exponents for x. The biggest I could take out would be the lowest of the 2. So x to the 1 or just x, we're done. Okay, now here we have 3 terms. So it has to be, greatest common factor has to be common to all 3. Okay, same process though, but this time we're checking all 3 terms. So we have a 6x cubed, negative 12x squared, 18x. Okay, so let's look at the number parts. I have a 6, a negative 12, and an 18. Okay, looks like all 3 of those numbers are multiples of 6. And since I have a 6, I definitely can't go any higher than 6. So 6 will be the highest. Now you might look at the negative 12 and say, well, shouldn't I put a negative here? You could. I would always pick the sign of, so if I had a negative 6x cubed, I would put a negative 6 here. So I always kind of go by the biggest, we call this the biggest degree. Okay, now would you be wrong if you put negative 6 instead of my 6 here? No, that would be fine. But later on, it's going to be advantageous to use the number, the sign of the biggest term. So if that was a negative 6x cubed, I would make this a negative 6. Okay, now we look at the variable part. So I've got x cubed, x squared, and x, which is really x to the 1. The fact that I've got x's in all 3, that's good news because I have at least that. And to find out the actual exponent, you pick the lowest of the 3. So I have a 3, a 2, and a 1. Lowest is the 1. So 6x to the 1 or just 6x. Okay, so these are the greatest common factors. This is the important first step into doing common factoring. Okay, so let's do our second examples where we actually find the greatest common factor and then use it to factor. Sounds confusing, I know, but let's go ahead with that. Okay, so the first, now we don't actually have like a list of terms. We have an expression. So this expression has two terms. If you wanted to think in terms of the terms, I have a 10x and a negative 15. Okay, so in terms of the greatest common factor, I'm going to actually do this over here. Okay, and then I'm going to use it back here. So greatest common factor is equal to, so I have a 10 and a negative 15. So I can put 5. 5 would be the biggest number that goes into both. Now in terms of the sign, like I said before, I'm going to go by the biggest degree term. So it's usually the first term of all the terms. So whatever sign that has, that's a positive. I'm going to use positive 5 there. If it had been negative 15x plus 15 or minus 15, doesn't really matter, I would have put a minus 5 there if that was a negative 10x. Okay, now we look at the variable part. So I have an x here, I don't have an x there. That means I can't use an x for both. So this means we're done. So that is the greatest common factor, just like our first example. Now we're actually going to go to the next step, and whatever the greatest common factor is goes right out front. So that is a factor of that expression. Okay, now here's where you put like an empty set of brackets, and I'm going to have, because there's two terms here, there needs to be two terms here. So I have to figure out what goes here, what goes here. So there's a couple ways of doing this. I'll tell you both ways. You could decide which you like best. So basically I know that 10x is going to be equal to 5 times whatever this is. So it's basically saying, what do I have to multiply 5 by to get 10x? Okay, so in this case, I'd have to multiply the 5 by 2 to get 10, and then I'd have to put an x in there as well to get the 10x. And here's, you can always check this, right? 5 times 2x needs to equal whatever that is, and it does. 5 times 2x is equal to 10x. So that's done. Now I need this second term here. So this term is what I multiply 5 by to get negative 15. So 5 times what gives me negative 15? And that's going to be negative 3. So the negative 3 goes here. So we've just factored this expression using common factoring. Our common factor was 5, and our other factor, when we took the 5 out, was 2x minus 3. Now the other way of doing this, and you might like this, you might not. So whatever the common factor is what you divide each of these terms by to get the other factor. So I could say, well, the first factor is going to be 10x divided by 5. That's 2x, okay? And the second one will be negative 15 divided by 5. That's negative 3. So we're really doing the same thing. One's using multiplying, one's using dividing, okay? Now, the best thing about factoring, there's not all that many best things, but you can always check your answer. So remember the first page, how we talked about, let me bring this back, how they were opposite processes, right? So when I factor something, I can always then turn it around and go, okay, well, let's expand this and see if we get back the original question. So if I actually multiply this out, I should get back to the 10x minus 15. Okay, so 5 times 2x, that's 5 times 10, sorry, 5 times 2 is 10, 5 times, sorry, and then times x is 10x, and then 5 times negative 3 is negative 15, and that does in fact equal the original question. So I'm just kind of going backwards. I factored it first, and then I expanded my answer, and I should get back to the original question. Okay? All right, let's try this one here. So this time we have, again, if you remember, binomial means it's two terms. You can see I've got a 20x and a negative 12x squared. Okay, so let's find the greatest common factor first. Look at the number part, 20 and negative 12. Okay, so don't worry about the negative right now. 20 and 12, what's the biggest number that goes into both of them? That would be a 4. Okay, now should I use positive or negative? This one, I could go either way. I'm going to go based on the first term. First term's positive, so I'm going to make my common factor positive. Okay, then I got the number part, variable part, I have an x and an x squared. That means I have at least an x here. Do I have a higher exponent? I picked the lowest of the exponents of the x's. Since that's x to the 1, that's x to the 2. 1 is the lowest, so that's all we can do. 4x is the greatest common factor. Go back here. There's my greatest common factor. Put my brackets. Now, how many terms go in here depends on how many terms you have in your question. Since I have 2 terms here, I have 2 terms here. Because when I multiply this with whatever this is, I have to get 2 terms. Okay? So again, you can use the approach you want here. I could ask myself, what do I have to multiply 4x by to get 20x? What is that number? Well, actually, sorry, that's a 1. That was my writing. What do I have to multiply 4x to get 20x? Well, to multiply 4 times 5 gives me 20. Okay, so 4x times 5, that's 20x. That means I'm done. I don't have to put in another x here because I've already got the single x here. Okay, but if that was x squared, I would need to put an x here. Okay, and then the second one, what do I have to multiply 4x by to get negative 12x squared? Well, 4 times negative 3 gives me negative 12, so I have a negative 3. And to get, I've already got an x here, I want an x squared, so that means I have to multiply by another x. So there's my factor. Common factor 4x. Second factor is 5 minus 3x. How do we know that's right? We check it. We just expand this back to hope we get the original question. 4x times 5, that's 20x. 4x times negative 3x, that's 4 times negative 3. X times x is x squared. Is it the same? Yes, it is. That means that's correct. Okay. Last one here. Well, last one in this example. This time we have a negative 3x squared plus 12x. So GCF, greatest common factor. Number part, I have a negative 3 and a positive 12. Well, it's definitely going to be a 3. Should it be a negative 3? I would say yes in this case because the first term, which is also the highest degree term, is negative. So I'm going to put my negative sign there. And then, do I have an x in both the terms? Yes, I do. So there's at least a single x. Should there be more? No, because that's x to the 1. That's x squared. It has to be the lowest of all the exponents. So that's my greatest common factor. So negative 3x bracket. 2 spots in there. Now let's try it the other way. Remember I said you could actually divide both terms by the greatest common factor to get what goes here. So what goes here is negative 3x squared divided by negative 3x. So the negative 3 just divided by negative 3, that cancels out. X squared over x, that just leaves me 1x. So that's all I got there. 12x divided by negative 3x. Well, 12 divided by negative 3, that's negative 4. X divided by x leaves me no more x's, just 1. Okay, so there's my final factoring, the greatest common factor, and this second factor that goes with it. Okay, let's check it out. If I was to multiply the first term, I get negative 3 times 1, that's negative 3. X times x is x squared. This term, negative 3 times negative 4, positive 12. X times, well, there's no other x there, so it's just the 1x. Okay, and that is the original question, so we know we got it right. Okay, this one is slightly different, but hopefully it's not that much of a stretch for you. So this time we actually have a trinomial, which means 3 terms. So we're going to common factor this using a GCF. Okay, so we did something like this in example 1 with 3 terms. So to find the greatest common factor, we just look at the number part for each of the three. I have a 3, a -9, and a 12. So it's got to be a 3 for the number part. Should I make it negative? No, I wouldn't, because first term is positive. Okay, what about x? I have an x there, an x there. I don't have an x there. So that means it's not common to all three. So we don't have a common variable factor. So that's done. And then we go to the final step. So our greatest common factor goes in front of some brackets. How many terms go in here? This time it's 3, because the original question has 3. So this is the difference between this question and example 2. The rest of it works the same. So again, you could say, what do I have to multiply 3 by to get 3x squared? Well, that's just x squared. Okay, what do I have to multiply 3 by to get -9x? That would be a -3x. What do I have to multiply 3 by to get +12? That would be +4. Okay, and let's check it out, see if it worked. So when I multiply 3 times x squared, I get 3x squared. Multiply 3 times -3x, -9x. 3 times +4, +12. Is that the original question? Yes, it is. So, no, we're right. Okay. All right. One more question. This is an application question. It's all, it's a word problem. I don't really like it that much, but I will be giving you something like this on your assignment this week. So just try to understand what we're doing, and then just kind of adapt the question to whatever changes of whatever's different from this example here. Okay, the liner notes for a CD, you can tell this is a dated question, form an area represented by the binomial 12x plus 3x squared. So the liner notes, it's a rectangular shape. We don't know the dimensions, but we do know that the area is equal to 12x plus 3x squared. Okay. Okay, so what do they want? Write an expression for the dimensions of the liner notes. So we've got the width and the length of the liner notes. They want expressions for these two things. Okay, so let's write out what we know. So we know the area is equal to the length times the width. We actually know the area is 12x plus 3x squared. So what do they want us to do? Well, you can kind of understand from the lesson, it's probably got something to do with what we've been doing the last few examples. We want to break this expression into two things that multiply to become this. Okay, so let's do the common factoring. Find the greatest common factor of this. Let's do it over here, give ourselves some room. So between 12x and 3x squared, what's the greatest common factor? I've got a 12 and a 3, so 3. And I have an x and an x squared, so for sure I've got x. Do I have anything more than that? No, because that's just x to the 1, x to the 2. Pick the lowest, which is x. So I can rewrite this as 3x times something. This might be the length, and this might be the width. So what should go in here if the one dimension is 3x? So this is where we do finish off our common factoring. So it's going to have two terms here because this has two terms. What do I multiply 3x by to get 12x? Well, that would be a 4. What do I multiply 3x by to get 3x squared? Well, the 3 is okay, so I don't have to put a number there. But I'm starting with an x and I want an x squared. That means I have to multiply by a single x. Okay, so the dimensions we could say that possibly this is the length and this is the width of so if we multiply the length with the width, we do get the area. So now let's actually plug a number in here. It says find the actual dimensions if x is equal to 6 centimeters. Okay, so if x is equal to 6 centimeters, then the length is equal to 3x, and x is 6, so that's 3 times 6, which is 18 centimeters. Okay, so we're just plugging in the value of x with what we already know. And the length is 3x, the width is 4 plus x, which is going to be 4 plus 6. Just plugging in the 6 there. So that's going to be 10 centimeters. So therefore the dimensions are, so remember that's the length, that's the width, 18 centimeters by 10 centimeters. Okay. Next question. Determine algebraic expression for the perimeter. Okay, so if you remember the perimeter, we go back to this, the perimeter is the sum of the outside area. It's like the fence, right? So whenever we have a rectangle, we have two lengths and we have two widths. Or we could just say, let's add the length and the width together and double it, because whatever that is the same as this. Okay, so our formula, let's do it, perimeter is equal to 2 times the length plus 2 times the width. That's a little more direct. Okay, so what's the length? Well, we go back to here. We know the length is 3x and the width is 4 plus x. So it's 2 times 3x plus 2 times, and the width was 4 plus x. So let's figure out what this is. 2 times 3x, that's going to be 6x. And 2 times 4 plus x, well, this is going to be, we have to do two multiplications, right? 2 times 4 and 2 times x. 2 times 4 is 8. 2 times x is plus 2x. We have two like terms here, 6x and 2x. We can combine those to become 8x plus the 8 that was already there. Okay, so there's our where we find the perimeter using the actual dimensions for part B. That's our perimeter. Okay, and again, this time we're going to substitute in x equals 6 centimeters to see what the actual perimeter would be if that was true. So the perimeter is equal to 8 times 8x plus 8. Well, x is 6. So 8 times 6 plus 8, 48 plus 8, 56. Okay, so what units should that be? Well, the perimeter is just adding up the outside area, which is, based on the fact that they gave us centimeters, this would also be centimeters. Okay, so perimeter is 56 centimeters. Okay, so I've got some questions here. I'd like you to try some of them, get the hang of what we're doing, and then I will be assigning you the final assignment for the unit, and I'll let you know when that will be. It'll be about the same length as the other assignments. Please make sure you get it on time, and also any other assignments that maybe you haven't had a chance to get in yet. If I start marking it and yours isn't there, I've already warned everybody that I don't have some of these missing assignments. If I'm missing yours and I start marking, it's going to be a 0. So you've had lots of time to do these. You've had lots of chances to ask questions, although I think I've only heard from about 3 out of the 21 in this class. So if that's what you choose to do, that's fine. But again, I'll be posting my office hours for this week. It'll be a little bit different because I have to go into the school. to help with the locker cleanups. So if you do need help and you're not really sure when the office hours are, check Google Classroom, or you can just send me a message on Remind and I'll let you know when I'm available. Okay? Thanks a lot, guys, and good luck.